We're going to go on to our continued section and do kind of a real life application and a few other things that we need to know. Real quick, let's do a vocab and concept check. See what we know so far. What does it mean for X and Y to vary directly? Go ahead and answer that real quick. Maybe write it down, maybe answer it in your head. Hopefully you're thinking it means for them to be in a proportional relationship. It means that X and Y vary directly, meaning that your graph is going to go through the origin, it's going to be a straight line, and it's going to have a constant rate of change. So go ahead and write a nice sentence there down next to that for what it means. And then the second one, what point is on the graph of every direct variation equation? This point will be on every single graph. And it was on every single graph of a proportional relationship as well. What point should that be? Hopefully you're thinking the origin, 0, 0. And if you are, you're correct. Let's get into a real life application. We have one of these robotic vacuums. Maybe you have the Roomba, those iRobots, something that might vacuum the floor for you when you all are asleep or not home. So it says the table shows the area Y in square feet that a robotic vacuum cleans in X minutes. I want to graph this data. So in half of a minute, it vacuums 8 square feet. In 1 minute, it vacuums 16 square feet. And we can go so on. What it wants us to do is first graph the data. So our X is our time, it's our minutes. So I'll label that. And then our Y is our square feet or our area. So area in square feet. So we're going to go ahead and we are going to plot these points. Notice I have a half and I have a 3 halves, or this is equal to 1 1/2. So I might want to count by halves here, which means every other one would be a whole number. 2. So you might want to do it like that. So we know that in between each one is a half. Like here, from 0 to 1, this would be half right there. Everyone, hopefully you're noticing that. So label your X, and then we'll go through and label our Y. Our Y is increasing by 8 each time. 8, 16, 24, 32. So maybe you want to count by 8. Maybe you want to count by 4, go up every other, so it's kind of spread out more. So again, if you want to skip one and do 8, skip another, do 16. So label that how you prefer. And once you have it labeled, go ahead and let's plot our points. So we have 1/2 8. So we go over half, which again we went by halves. So I should be going over to the first tick mark up to 8 and putting a point. There's not a point there, there's a point there. 1/16. 1 1/2, 24. Where 1 1/2 falls between 1 and 2. And then 2, 32. Once you have that, connect your points. Now I want you to think about this. Would the point 0, 0 be on this graph? If you need to, kind of figure out how much we're increasing by and would it go? Or just think more logically. If the Roomba's running for 0 minutes, how much of the floor would it clean? Would it clean any of it? No, right? So it would fall on our graph for 0, 0. So if you want to add that, you can. So tell whether X and Y are varying directly here. Are they directly proportional? Well, look at your graph. Is it a straight line? Yes. Will it go through the origin, which I just showed you and we just discussed? Yes. So tell whether x and y are directly proportional? We would say yes, because it's straight and goes through the point 0, 0. Now, write an equation that represents the line. Remember, our direct variation equation is y equals kx. When you're trying to write an equation, we have to figure out what our number would be. Remember, k is always a number, and we have to figure out what that number is. Now, if we remember back to our first page of notes here, k is also the slope. Okay, if we look back here, it says the graph of y equals kx is a line with a slope of k. So we need to find what the slope of this line is and replace that for k in our equation. So let's figure out our slope. So choose any 2 points you want, and we're going to do our rise over our run. I'm going to suggest 2 points that aren't right next to each other, and I'll show you why in a minute. So let's rise. So I went up 4, 8, 12, 16, and I went over, remember, we counted by halves. So 1 half, 2 halves, which is a 1 whole. So 16 over 1. That is our slope, or we could just say 16. So what I want to do now is replace k with that number. So our equation would be y equals 16x. That's our answer here. We always leave x and y as the variable and replace k with a number. Now let's do part C. Use the equation to find the area cleaned in 10 minutes. So now we're going to use this equation, and if I want my minutes to be 10, what would be the area? Remember, minutes is our x value, so I'm going to plug in 10 for x in our equation to find our y, which is our area. When 16 and x are next to each other, they're being multiplied. So multiply those together, we get 160. So how much area is cleaned in 10 minutes? 160 square feet, or feet squared. Nice work. All right, lastly, real quick, let's go through these questions real quick. What do we need to know to decide whether x and y vary directly with each other? We need to know first, will the graph be straight? And we also need to know, will it go through the origin? Straight and through origin, or through the point 0, 0. So I'm going to kind of abbreviate here, but write as much down as you need to. Compare and contrast direct variation and proportional relationships. Well, guess what? They're the same thing, right? We're always looking for a graph that is straight and goes through the origin. The only thing that direct variation includes or adds was our equation y equals kx, where k is a number which represents the slope of the line, now that we know slope. And lastly, true or false, direct variation is the same as being proportional. Is that true or false? Hopefully you're thinking true. If you are, you are correct. And I cannot highlight it because it's in my way, so go ahead and circle true. Direct variation is the same thing as deciding whether or not that graph is proportional, or if that table is proportional, or whether that equation is proportional. Okay, we're just bringing in more factors here. We're bringing in our slope, we're bringing in an equation, y equals kx. We're just using some maybe fancier word, direct variation. But that's the same thing as saying it's proportional. All right, I know that was a lot to take in, so let us know if you have any questions. Maybe go through the video again as needed, or specific problems, and let us know what you need help on, and we'll practice this.